Engineering Eng. PDF document of this video is on engineereng.com.
Hello friends again. We proceed the cylindrical coordinates in our previous video. Now we will proceed the spherical coordinates. In spherical coordinates, our units of length are r, theta, and phi. If you wish, let's show it here again. X, Y, and Z. And we again have a length r here again. This is the observation point. Now I project point P in this area again. When you're looking here, let's draw again here correctly to understand correctly. Now friends, here that we call the angle we made with Z theta. Then our purpose is, look at this, I drop perpendicular to Z. I project the xy plane as the point P prime. Now we know again that the angle with x is phi. Now if you notice friends, you know that length was rho. But if you pay attention, there is no length called rho in this coordinate system, because rho is the element of cylindrical coordinates. Now if you pay attention, there is a help from this point that length is equal to the vertical projection that I dropped there. So this and that are equal, friends. Then that is rho. Now a question for you guys. You can see the right triangle with the hypotenuse r here. That is, I have a right triangle. Let my perpendicular length z be the other perpendicular length rho, and my hypotenuse is r. I even know that the angle between Z and R is theta. So, how can I express Z in terms of R and theta? Z equal R cos theta. So, how can I express rho? Rho equal R sin theta. After I know this, let me express r again. Normally, I can write as r equal x ex plus y ey plus z ez in its most general form. Now see how I am converting this to spherical coordinates. Again, in this previous cylindrical coordinates video, I had written this for x rho cos phi ex, rho sin phi ey for y, z ez for z. So that Cartesian, that cylinder, now look how I'm translating it into a sphere. See what I found rho. R sin phi rho fulfills R sin theta cos phi ex. Again, instead of rho, R sin theta sin phi ey. And see what I found that I brought it here and wrote it in the form of R cos theta ez. I have found all three of them. I have expressed Cartesian, cylindrical, and spherical in this way. Now let's take a look at the matrix part again. My goal here is to to see how we can find HR, H theta, and H phi. Now, if you wish, let the length of the sphere stay here in this region. Let's first look at how we found it. Now, R is certain here. Let's start with HR at first. Let's remember again. Let's have a kind of proof. Will HR be 1? Now we need to see this. Take the derivative of dr with respect to r. Then you will find HR. Now, what do I find if I derivative them with respect to r? HR equals sin theta cos phi ex, and sin theta sin phi ey. Look, here there is r, so I take its derivative plus cos theta, so r goes to ez remains. I want to find the size of this and find it that way. What will happen when I find it, guys? It will come in the form of squares of these. Then HR, this one, HR equals sin squared theta cos squared phi plus sin squared theta sin squared phi plus cos squared theta, which is equal to, look at there, sin squared theta, if I put it in bracket, cos squared phi plus sin squared phi plus cos squared theta. Isn't that 1, friends? If this is 1, what stays here? Let's write it over here, which is equal to sin squared theta plus cos squared theta, which is already 1, guys. Therefore, I have found HR. I have already proved this question mark. Let's do the same to find H theta. What should I do again in H theta? I take the derivative of dr accordingly. First of all, if I take the derivative according to theta, will it come? First of all, I'll write this directly to fill in it. And I take the derivative accordingly theta. The derivative of sin is r cos theta cos phi ex minus r cos theta sin phi, and here I am rewrite again. Here is the plus because we took sin theta. Here is minus because cos is theta. R sin theta Ez. Now, in the same way, when I square the derivative and enclose the root, I try to find H theta as follows. What will come from here, guys? R squared cos squared theta cos squared phi plus r squared cos squared theta sin squared phi. The product of minus to minus will make r again because I have squared of them. R squared sin squared theta in root. Now all of them has r squared, so h theta equals, if I put them all in parentheses, r squared in the root, when I find hr, the remaining lengths will remain the same. So cos squared theta cos squared phi plus cos squared theta sin squared phi plus sin squared theta. I just found 1 from hr. You will see if you calculate it. R squared, this is equal to r. Hence we found h theta as r. Now let's finally find the h phi and complete this process. Now, look guys, I will tell you something like this. I say what I expect to find before. Once we found h phi as rho in cylindrical coordinates. What had we just found rho before? In a right triangle, it was here rho, here z, here r, here theta. What did we write to rho? We wrote r sin theta. Now look friends, we actually h phi, it will not change here. It will be rho, but since rho does not have an expression here, I say we will find h phi as r sin theta. Let's see if we can find h phi as r sin theta. Let's do it again. Then what was h phi equal to? I will take the derivative of r according to phi. I open this derivative operation as follows. See here, I will take the derivative according to phi, square it and enclose it in the root. What is the derivative of cos phi with respect to phi? Minus r sin theta. What will I write instead of cos sin phi? Likewise, here the derivative of sin phi is cos, then plus r is sin theta cos phi. I say plus 0 here since it has no derivative with respect to phi. Now friends, if I take the square of this and multiply it by self, what I found r squared sin squared theta sin squared phi plus r squared sin squared theta cos squared phi. Since r squared and sin squared theta are common here, if I put r squared in the sin squared theta bracket, I get sin squared phi plus cos squared phi. This size of it is 1, friends. So what we found h phi equals r squared sin squared phi in the root. It comes out as r sin theta outside the root. Here we have proved this again. I mean, it actually equals rho. We have seen that. But since the expression of rho in terms of spherical coordinates is r sin theta, I have expressed the result as r sin theta again. In summary, after find matrix in this way, let's write dl to dl, ds and dv software in spherical coordinates. For example, let's write for r in the direction of er, in the direction of hr with a length of dr direction. Here is 1 because its length automatically er dr. Let's write dl theta. E in the theta direction, h theta d theta direction, e theta small r d theta. How do I write dl phi in the direction of e phi? h phi d phi was equal to h phi rho, but we found out what is, because there is no rho. Let's go to ds after writing dl in the form of r sin theta dv. After writing dl in ds again, we do not forget that er, e theta, and e phi are positive when clockwise, right? I know that they are negative when counterclockwise. Now let's write phi and r accordingly. When you look, what will write first? Phi have r. There is no theta, then there is h phi, h r, d phi, dr in the direction of e theta. Now here I see that it's increment and minus. After phi it remains positive because r is clockwise. This equals to e theta direction, h phi r sin theta d phi dr. Let's write ds for theta and r. Minus because it's clockwise while going from theta to r. Which one is non-existent? E phi, h theta, h r, d theta, dr. H theta equal to r and hr equal 1. R d theta, dr in direction of E phi. Finally, let's write ds for the phi theta. Since it is counterclockwise when going from phi to theta, it is minus, which one is non-existent again, in the direction of er, h phi, h theta, d phi, d theta. This is also equal to this. I am writing at the bottom. In minus er direction, what is h phi? R sin theta, r d phi, d theta. If we arrange it in the bottom again, this is equal to minus er direction r square sin theta, d phi, d theta in the form ds phi theta. We write it like this, my friends. Finally, let's write the volume again. In the volume, friends, r equal to the 3. We can write the product in the form of hr, h phi, h theta, dr, d theta, d phi. From here, it is in the form of sin theta, rd. From here, it is in the form of 1 r sin theta, r dr, d theta, d phi. As a result, dv is equal to r squared is found in the form of sin theta, dr, d theta, and d phi, my friends. This is how we have proceed the global coordinates. Hope to see you in our next lesson. Goodbye for now.